When we talk about normal distribution, we're always referring to the bell shape. The graph looks like this. Most experiments, if it's done correctly, the graph will look like that. That's called the standard normal distribution. So the standard normal, so this is the standard normal distribution, the word standard. When we talk about that, what does that mean? Couple of things. The graph has what? We said bell shape. This is the mean right here. The second one, the mean is equal to 0. So mu equals 0. Another thing about that shape, the standard deviation, if you do it, standard deviation equals 1. So sigma equals 1 for it. So when we talk about standard normal distribution, we're talking about a graph that looks like this with the mean being 0, the standard deviation being 1. Bless you. And this actually, soon enough, this shape becomes a probability. And the area under that becomes the probability of some event. Now, if you look at that graph, you'll find a few things about it. One of them, that if this is the x-axis or that's the 0, the graph will never actually touch that. Come closer and closer and closer and closer, so it never stops. Like this. It goes out on both ends. If you can figure the area under that, you can use your calculus trig, fancy calc techniques that you know from Calc 2, Calc 1. Calculate the area under that. You will find the area under that is equal to what? Always a 1. Why is it always a 1? Because this represents the probability. And when you take the probability of all the events, you add them, what's the sum always equal to? 1. And if you slice that in half, it is symmetric. So if you take a knife, you slice it in half, it's symmetric. Half it to the right, half it to the left. So a lot of times you hear the word spread evenly. Evenly means symmetric. So again, couple of things about it. The area is 1. Every point on the graph, you pick any point here, must have a height that is greater than 0. It could be 0 because they represent probability. Remember, the probability of any event is always between what? 0 and 1. And the sum of the probability is always what? So this still applies. The area is really that answer. The height of each one between 0 and 1 will never be negative. Every once in a while, we talk about something called uniform density function. Let's talk about uniform density function. This is not a uniform density function. So let's assume I'm given the uniform distribution below. Now let me give you a picture of it. This function, it's only good Let's say I'm studying that voltage coming out of that outlet, since we're dealing with engineers here. Studying the voltage coming out of the outlet. The voltage in the US is what? How big the voltage here? What's our voltage? 120. So let's say we calculate the voltage, and we found out all the voltage that we measure, they're between 124.5, a little bit higher than what we're supposed to get, and 125. Or even, let's make it bigger. That's not a good voltage actually. But let's say between, instead of 124, where's my eraser? If I do that, I'll leave it there. If I do that, then what is the height of that supposed to be? If this is uniform distribution, probability I forgot the word probability here. Uniform, given the uniform probability distribution below. If that's probability, then what's the height of that has to be? So all the voltages are right there. What's the height of that?
It's got to be 2.
It has to be 2. Why? Because the area always has to equal to what? 1. So since the width is what? 0.5? 0.5 times 2, that will give me an area of 1. The problem with this, if this is probability, we got a problem with my story here. Right? What's the problem with this story? The probability of any event is always between what? 0 and 1. So to have a probability of 2, we got an issue there. So that means my story wasn't right. When we measure the voltages, let's say the voltages happens to be, instead of being between 124 and 125, it just happens between 123 and 125. As we kept measuring the voltages, we found the answer between 123 and 125. So in this case, then the height will have to be what? 0.5. Why 0.5 again? You want the area to be 1. The width here is what? 2. 2 times the height equals to 1. The height will have to be 0.5. That's a better problem now. So when we talk about uniform distribution or uniform probability distribution, we're talking about constant value. Should have the word probability. So if we have a uniform, we have a constant value. If I said to you, assuming this picture is good, the bottom one, the top one is not good because the probability is more than 1. But assuming this picture is good, that's a true actually problem there. If I ask you what is the probability that x will be greater than or equal to 124.5, what will happen if I take a meter, plug it in, I'm going to measure a voltage larger than 124.5, assuming all the values between 123 and 125. So you will never get anything more than 125 and anything below 123.
Quarter.
Why is it quarter?
Because it's a uniform distribution. Each slice is equal.
So this is the 124.5. It says greater than or equal to. So we're talking about that area. That's what we're talking about. Has to be bigger than 124.5 or equal to. A line itself does not have an area. So if I put equal or not equal, it doesn't matter. A line does not have an area because there's no thickness to it. So what's the answer to this? What's the shaded area there? The width times the height. What's the width? 0.5. And what's the height? 0.5, which is what? 0.25. So there's 25% chance that if I take my voltmeter and plug it into that outlet, I'm going to measure a value between or greater than 124.5. Another example. Let's say the pressure on the car tire. And now I'll show them how stupid I am when it comes to cars. I have no idea what the normal is. What, 33 the normal? Anyone knows?
Yeah.
So we'll say between 32 and what? 35, 36? Let's assume if all the cars out there have a uniform pressure between 32 psi and 36 psi. If you measure the pressure on the tire of your car, it's between these numbers. It's uniform. So that means the height of that will have to be what? The area has to be 1. Area is width times height. What's the width from here to there? Is that 4? What's the height? H? 0.25. So the height has to be 0.25. So here's the question now. What is the probability if we take our pressure gauge and we go outside at random, pick some cars? The car is either underinflated or overinflated. Underinflated, this one will say the pressure is less, well, let's not use pressure, P is P. Let's use X, the pressure. X is less than 33 or X is greater than 34. Less than 33, we're talking about, where's the 33? This is the 33. Less than that, we're talking about this area. Or overinflated, this is the 34. Larger than that, or you in this group. Well, if you look at them, that's an OR operation. It's either less than 33, add to it, greater than what? 34. You can't subtract the overlap. Why? How can a tire be below 33 and over 34 at the same time? One tire can't be. So they're mutually exclusive. You can't be in this and in that one. So under the 33 here, the width is what? 1. The height is 0.2. 0.25, sorry. So that's what, 0.25? Over the 34, the width is what? 2. The height, 0.25. What do we have? 0.5. So there's a 75% chance that if we take our pressure gauge and go outside at random, based on this information given to us, that the pressure in a car tire is always between 32 and 36 and it's uniform. So when you see the word uniform, that's what they're talking about. Just in real life, you never deal with that. You always deal with bell-shaped. The standard normal distribution. So let's look at that, the standard normal distribution. I want to talk about this, but reality says, nah, you're not going to see that. You might see on the homework for one problem, but that's it. So standard normal distribution. We said that means bell shape. Oh, that's supposed to be even or symmetric. That doesn't look symmetric. There we go. something like that, close enough. We said the area here is what? 1. This is the mean. When you look at, when you start talking about the standard normal distribution, we talk to the z-score. So this is the 1, this is the 2, the 3, the -1, the -2, the -3, and so forth. So these are the z-scores on the bottom. You'll need that. A standard normal distribution has a mean of equal to what? 0. Has a standard deviation equal to what? 1. The area is equal to 1 under it. Bell-shaped. So anytime we talk about the standard normal distribution, that's what we're talking about. Now, to find the area, so we're going to figure out how to read that table. If you want to find the area, I wish I printed that, the handout. But if I want to find the area to the left of z equals -1.42. How about 1.78? The picture I have on the screen I'm going to show you right now, I don't have a 4.2 on it, so I'll go with 7.8. I want to find the area to the left. How do we figure out that area there? So we're going to learn how to read that bell shape. Or I want to find the area to the right of 2.56. Or I want to find the area to the left of -0.92. Or I want to find the area to the right of -0.7, to the right of that. Okay, let me switch cameras and show you on the screen. We are not going to calculate that. There's an equation, by the way, for that, and if you saw that, I don't think I could integrate that. And I'm very good in calculus. So nobody does the integration on them. Let me see if I can find the equation for you, for those people really interested, what that integral is. Maybe I can Google it on YouTube and see what that equation is. Very quickly, let me find that equation on not YouTube, on Google. I want to say YouTube. Google. The equation for the area under the standard normal distribution. Did I say the equation? I hope I did the equation. I don't want the calculator, I want the equation. See if I can find that ugly equation. Oh, I got it. If you want to find that, you can use calculus for that. Be my guest. And to find the area here, you got to integrate that. Ready? From -infinity to -1.78, 1 over sigma times the square root of 2 pi times e to the power of negative what? X minus mu squared divided by 2 sigma squared. Sigma is what? 1, mu is 0. So if sigma is 1, mu is 0 for the standard distribution, what are you going to have? Sigma is 1 over the square root of 2 pi, e to the power of negative what? X squared over 2, dx. How would I integrate that one? Bless you.
Thank you.
How would you integrate that one?
Take the 1 over 2 pi, or 1 over square root 2 pi out.
Yeah, you can. So let me just go on a nice clean sheet. Let's see how we're going to integrate that. That's a constant. I'll agree with you. 2 pi out. I still have e to the negative x squared over 2. Good luck integrating that one. This is not e to the x. You can't use u substitution. For u substitution, you need an x here because you're going to let u equals this. You need an x here. You don't have that.
Can't you just do the whole, like, can't you just do x over x and then move the 1 over x out of the integral?
Can't. Not out of the integral. Yeah. You can rewrite that as, e to the negative x over 2 times e to the negative x. When you multiply, you add the exponents. But to break an integration, we have multiplication. We don't know how. We know if it's addition, subtractions. I think you probably did. It's called something called convolution theorem, maybe in calc. Maybe not. But here's the good news. We don't have to integrate that. So there is a way to integrate this, but we don't know it. You took calc 1, calc 2, you didn't cover that. So how are we going to find the answer? We're going to find the answer without doing any of this math. How would I find the answer to this? I'm going to switch here to the screen. And there is one of the handout I gave you is called normal distribution. What I put on the website for you. If you printed that sheet there, anyone has those pages that say print them? Anyone has them handy?
What are you looking for?
The handout that I put on the website. There's about 10 pages.
No, just which equation you're looking for. Equation?
Normal distribution. Not that equation. Yeah, it will be one of those tables actually. Right here. I got them. Thank you. Right here. Let me just borrow that for a second.
Sure.
So I don't have to switch back and forth. I want to find the area to the left of negative 1.78. Notice this is a negative z-score. You see that? Negative. I have two tables for normal distribution. One is called the negative score. One is called the positive score. Can you see them? Two of them. This is the positive score. This is the negative score. This is to replace the integration. This is the z-value. Since our z-value is negative, I'm going to be looking at the negative one. But either one, if you look at either table, they're going to give you the area to the left. My question to you was, what was the area to the left of negative 1.78? So that's a negative z-score. I need to find the negative 1.78. Two things to look for. Look on the left side here of negative 1.7. Can you see it? Negative 1.7. That's right here. So what is the negative 1.78? Notice there are 10 numbers. Now what are these numbers? This is for negative 1.70. This column is for negative 1.71. This is for negative 1.72, 1.73. We need to go how far? 1.78. Where they cross each other, And what's that number? Negative 0.30375. See that number? That's the answer. I don't have to integrate nothing. Negative 0.037, like not negative. The area will never be negative. 0.0375. Let me try it again. Let's try this one, negative 0.92. The first decimal place here, that's the left column. The second decimal place is the top. Negative 0.92. Let me find the negative 0.9 here, which is down here. I need 92. This is 909192. And what's the answer? 0.17. Is that 68 or 88? I can't tell. I think 88. 0.1788. What about this one? 2.56 to the right. Is that a positive value or negative value? Positive. So I got to use the positive z-score. 2.56. There's the positive z-score. Where is the 2.56? This is 2.56. That's the 5.6. The 6 here, the 2.5. And that's 9948. If you put that answer, you got it wrong.
You subtract from 1.
Exactly. Because if you think about it, this is 1. The whole thing is 1. This is 0.5. How can that area be more than 0.5? If it's from the dotted line to the right, all of that is 0.5. Then that piece has to be less than 0.5. Remember, the table always gives you the area where? To the left. That 0.9948 is actually this area. That's what that number is. I don't want that. I want it to the right of that. So since the whole area is 1, it's 1 minus that number. Which is what? 1 minus 0.9948. 0.0052. Now, a lot of people will say, oh, that's a lot of work. It's not really a lot of work, but 1 minus that number. Could you get the answer in one step? Sure we can. When I talked about the standard normal distribution, I said it has a bell shape. What else? I wrote something about it. Where is it? Symmetric. Symmetric, even. Which is what? That means if you want to find the area to the right of 2.56, is it 2.56? Yep. That should be the same as to the left of what? Negative 2.56. It's a symmetric picture. So if you want it to the right of 2.56, look at the negative 2.56, look to the left of that. And this way, I don't have to subtract nothing. Let's see if we end up with 0.0052. Same answer. Let me look to the left of negative 2.56. Negative 2.56. 2.56. 0.0052. Was that the answer? Yep. To the right of negative 0.7. Again, I can find to the left of negative 0.7. The z-value should always be 2 digits, actually, 2 decimal places. This is one decimal place. So what's the second digit then? 70. So we can look to the left of negative 0.70. Where's negative 0.70? 2420. That's this area. So if I want it to the right of that, that would be what? 1 minus 0.2420. Which is 0.758. Let's give you a few problems to try. And I'll put that chart on the screen there to see in case you don't have a copy with you. So remember, nobody really wants to integrate these. You got to be out of your mind to integrate them when we can get to the answer a lot quicker and easier. Let's say I'm looking for the area between 1.32 and 2.05. 1.32 and 2.05. These are positive z-scores. So let me put the positive z-score table so you can look at them and see what numbers you want to use. So how are we going to find that? Well, if you look at that picture, if I just did the 2.05, I'll do it in two steps. If I did the 2.05, I'm going to get this area. And if I did the 1.32, I'm going to get that area. So what should we do then? Subtract them in. Good answer, Jenny. Because look, if you look at them in one picture, it's hard to see in two pictures. Here's the 1.32. Let's say 2.05 right here. We're talking about this area, the green one, right? And the 1.32 is this area. It's the red one. If you take the green minus the red, don't you get the area what you're looking for? So that's how you find what's in between. I look at the 2.05. 2.0 and 5 is right here. Oh, that's a negative, sorry. Positive z-score, 2.0 and 5 right here. 9798. Subtract from it 1.32. 1.32, where's 1.32? 1.32. 0.9066. 6 from 8, 2, 6 from 9, which is what? 3, 0 from 7, 7, 9 from 9, 0. 0.0732. The book is not going to actually write the question, find the area. So what they're going to say, the probability, because the area will represent probability here. The probability that the z value is bigger than 1.32 and less than 2.05. That's how they're going to write that question. Find the probability, find the area between 2.05 and 1.32. Now, let me try this question. You try it. Find the probability that z between -1 and 1. You should know the answer to this.
0.68.
Yep, 0.68. Why? What's the definition of standard deviation? We talked about it. We said what percent of the values within one standard deviation? 68% of the values within one. That's where the number came from. Let's see if it's true actually. So let's find the area for the 1. This is the 1, the 1.00. This is the -1.00. We need the area between them. So I'm going to look at the 1.00. The 1.00 is 0.8413. Subtract from it the -1.00. Where's the answer for the -1.00? 1587. Seven from 13. Is it 8 or 6? 6, I think, right? Not 8, 6. That's 15. 8 from 0, you can't. 8 from 10, that's a 2. 5 from 3, we can't. 5 from 13, which is 8. 1 from 7, which is 6. 68% of the values within one standard deviation. Do you recall what was the value for 2 standard deviation? 95%. Let's see if that's 95%. That's actually where the numbers came from. This is the 2. This is the -2. We look at the 2.0, positive 2.0. Here's the chart. 2.009772. -2, that's 2.00. Negative 2.00. 0.0228. And let's subtract them. 8 from 2. Can't. 8 from 12. 4. 2 from 6. 4. 2 from 7. 5. 0 from 9. 9. Roughly 95%. 95.44% of the values within 2 standard deviation. We can do 3 standard deviation, which is what? 99.7. Yep. So that's how we came up with the numbers, not just guessing. We use the normal distribution table to get these numbers. Sometimes we can work the problem backward. What does that mean, working the problem backward? We can give you the percent and you say, can you tell us what the value is? So this is working backward. We'll call that finding the z-score or scores when given probabilities. I'll make an interesting problem here. SAT scores. The new SAT score is now out of 2,400. That's the highest. 800 for the math, 800 for the English, 800 for the writing. Let's say the average SAT scores for a student, if we look in the Springfield area, probably going to be the average here of 1,500. 5, 5, and 5. Most people are around that number, 470, 520. Every once in a while you get somebody who's maniac who score 800, 770, 750. You know, some people they give you 200 points for 300 for writing your name there. So it's amazing. Sometimes people say, I got 700 on the test. Well, they give you a couple 100 just for leaving it blank almost. You know? And let's say that standard deviation is 200. Let's say Springfield Technical Community College. So we're only going to accept the top 20% of the applicants. When I say top 20%, we're talking about SAT, top 20% on the SAT. So what is a score that you need to get you to Springfield Technical Community College? What score do we need? Bless you. So this is what Stick's saying, STCC. For people who don't know us on the video, we're a community college in Western Mass, tiny school. We're going to accept the top 20%. That means I'm telling you this area here is what? Is 20%. Those are the people we're going to accept. 20% as a decimal value, that's what? 0.20. That means we're going to reject what percent? This we're going to be accepted. This will attend STCC, will not attend. And the people to the left will not be coming to Stick. The people to the right will be coming to Stick. So we're rejecting what percent? 80%. 0.80. 80%. I'm trying to find what SAT score will get me to STCC. I just took my SAT and I scored 1375. That's my score. Z-score. Am I going to be going to STCC or not based on that score? I need to know. I can do the math here, work the problem backward, and see. I can find the Z value that corresponds to 80%. Here, you got to think backward. I'm giving you the area. I'm telling you what the size of the area. Can you tell me the Z-score? Now the fact the area is more than 0.5, notice that's more than 0.5, that tells me the Z value is going to be what? A positive number. 0.5 and less, all these will be negative. To the right, that will be positive. So I got to look at the positive z-score, and I got to look backward, meaning what? Look inside the table, find the closest number to 0.8000. So what is the closest number to 0.8000? I see 0.7995 and I see 0.8023. Which one's closer to 0.80? 7995, right? So the z value for that based on this is what? 0.84. Everyone see that? 0.84. That's the z value. That will give me 80% to the left, 20% to the right. If you remember from chapter 3, to calculate the z value, we said it's x minus mu divided by sigma. I forgot to give you, with this the average. We know what the average is. This is what we said the average. This is sigma. So the z value is what? 0.84. I'm trying to find the cutoff number. That's x minus mu, which is what?
0.
Mu, no, for the SAT scores. 1500. And the standard deviation is what? 200. I can tell you there's nowhere in hell I'm going to stick with these numbers. Because I got to take the 200 times 0.84, and that's 168 equals x minus 1500. X will have to be what? 1680? Or 16, no, I added wrong, right? 1668, yes, thank you. Next to 0. So I have to have a minimum SAT score of 1668 to get to STCC. Is 1375 going to get me in? No. I better save my money, don't even apply. Because they're not going to accept me. Now you want to see some impressive numbers? Look at Harvard and Yale acceptance rate. 0.07% last year. 7%, 0.07, that area. 93% of the people get rejected. Here's the difference. 93% of the people applying to these schools, their SAT average probably 2200, I mean. Everyone almost has a perfect SAT there. So 2200 probably standard deviation maybe 100. They're all like next to each other. So do the math backward and see what SAT will get you to Harvard. If Harvard acceptance rate is 7%, top 7%, that means this is 7%. It rejects 93%. This is for Harvard. That means the z value for the 0.93, let me go inside that, the closest number to 0.9300, look inside that table, 9300, keep looking till you get close to that. I got 9306, is that close enough? 1.48. Now again, the difference between STCC and Harvard is the average SAT. For students applying to Harvard, probably their average SAT is at least 2200, at least. Standard deviation, let's say is 100. This is the average. So now you can work the problem backward to see what score you need to get to Harvard based on your SAT. And that would be what? X or Z equals X minus mu over sigma. The Z value is 1.48 equals what? X, which is unknown, I'm looking for it, minus 2200 divided by 100. This is 148. And Harvard says if you want to come to us, you better be ready to have SAT score 2348. Perfect score is what? 2400. You got to be near perfect. Yep. And I'm not making these numbers up for Harvard. It is 7%. So is Yale. Yale last year was 6% acceptance. Does everyone who applies to Yale or Harvard have to have a score of 2348? No, but you got to be close to it. Other factors involved with that too. You probably listen to people saying, I know somebody who applied to Harvard and got denied with perfect SAT scores, 2400, and they get denied because they're looking for the total package. They don't want somebody who just sits home and study all day long. What else do you do besides studying? Do you play music? Are you a dancer? Are you an athlete? Are you a community leader? Do you work in the community? What activities do you do? Because that will actually change their mind when they look at your application.